So the area of the entire parallelogram is 112, and the area of the square is 64. So if this area is 64, then the dimensions are 8 and 8. And I can think of this as the area of the square plus the area of these two regions is going to equal 112, and those two regions are going to be equal. So to find out one of them, I take 112 minus 64 divided by 2. And this turns out to be 24. So that's the area of this triangle here. So the area of a triangle is base times height divided by 2. And I know the height is 8. So I can plug in the area, which is 24, and I can plug in the height, 8, and from there it's just solving it. So 48 is equal to 8b, or b is equal to 6. The base is 6, which is A. The area of a square is 36, so area is equal to side length squared. So S is equal to, or S squared is equal to 36, or S is equal to 6. And we're done. Here's a table representing the perimeter and area of a square. So the perimeter, you might recall, is 4 times the side length, and the area is equal to the side length squared. So how do we get from 4s to s squared? So if we square this side, we end up with 16s squared. So we're part of the way there, and what do we go from there? We have to divide by 16. So square it and divide by 16. If we draw a line straight down, we have a square and a triangle. 4 times 4 is 16. If this is 4, then this is 3. Pythagorean theorem says, well, don't need it, 4 is over there. So just 4 times 3 divided by 2. So this is 6. Add them together, you got 22. The formula for the area of a trapezoid is to take base 1 plus base 2, average them, and multiply by the height. So if we're going to take trapezoid A and make all sides 8 times the length, effectively, this part will be multiplied by 8, and also this part will be multiplied by 8, the height. So there's a total factor of 64. If you weren't sure what you're doing, you could try a test case with some actual numbers for every side length and build from there to figure out the height and the area, and then multiply by 8, and you would find that 64 works just fine. So this is everything that's given. AB and AD are the same, BC and CD are the same, and since BC is 4, CD is 4, this entire length AC is 10, and BE is 2. First, I will deal with this triangle here, and I'll use the Pythagorean theorem to figure out this missing side. So this is 4 squared is equal to 2 squared plus x squared. So 16 is equal to 4 plus x squared, or 12 is equal to x squared. X is equal to the square root of 12. Now I'm going to simplify that by saying that it's equal to the square root of 4 times 3. So I can pull out a 2, so it becomes 2 root 3. And I'll write that in up here. And since 4 and 4 are the same here and there, and they share this length, I can also identify this distance as 2. So since the entire AC is 10, this part here is going to be 10 minus 2 root 3. And if I look here for my height of my triangle, or I guess I could say my base, depending on how you look at it, I'm going to have base times height divided by 2, where my base is 4, my height is 10 minus 2 root 3, and all over 2. So I can simplify this to 2 times 10 minus 2 root 3, and if I distribute the 2, I have 20 minus 4 root 3. C. With the givens, we know that this is an isosceles trapezoid. If we call this B1 and this B2, and this is our height, the original area can be found with the formula B1 plus B2 divided by 2 times H. For the new area, we're taking double the first base plus double the second base divided by 2, and we're taking half of the height. So if you double this side and you have that side, you're not actually changing the area. The original dimensions of a photograph, 5 by 7, or an area of 35. If we are now multiplying that by 2.5, because that's the equivalent of taking 250%, we're going to get 87.5. So the answer is B. So we're looking at a rectangle. The longer side is A, and the shorter side is B. If you add up the two shorter sides, so B plus B, and one of the longer sides plus A, we get 36. What value of A maximizes the area of the rectangle? So we can plug in these different numbers here for the blank, and you get these different B values respectively. So to find the area, we're going to multiply by 9, by 12, by 18, and by 24. The one that is the biggest is here, which was C, 18. So we have a square field. The measurements are 10 by 10, so 100 meters squared. And we're marking off regions. Each region has a side length of 1. So there's 100 regions, which are 1 by 1. And we're going to pick 10 of them, because 10 students each pick one at random. And if you look at the number of earthworms, and we try to find about an average, and I'm also kind of looking at the answer choices, I'm guessing that the average is 150. If we want to know how many earthworms are in the entire field, we're going to multiply that by how many possible regions there are, which is 100. So another way of multiplying by 100 is adding 2 zeros. So the answer is 15,000. So if this is our original rectangle, it has a length and it has a width, and we're going to a new rectangle, and the length is now 1.1 L, and because we're increasing by 10%, and the width is now represented like this. We don't know exactly how much we decreased by, but we do know that the overall area decreased by 12%. So LW, if it was 1 over here, it is now 0.88 over on the right side. So I would probably pick some numbers like 10, and then over here the length becomes 11. So if the length is 11, how do I get to 88%? Well, the width is now going to be 8, because 11 times 8 is 88. So how do I get to 8 from 10? Because this on the left here was 10 by 10. I have to decrease by 20%.